Good morning. So today we're not going to do a review for the lesson because yesterday you had your test, so we're starting a new section, new material. And we're on lesson 153, which is page 275. There's a lot of stuff in our facts section, so that's where most of the time is going to be spent today. And we've already learned about latitude and longitude in history class, and you might wonder what that has to do with math, but the thing is, longitude specifically affects time and different time zones around the world, and time is a math skill. So that's what we're going to work on today, and I think you'll find it a pretty basic concept to understand, but it explains why we have it and what's the purpose and how they're all different. We're just going to cover the time zones in the US. So if you're looking on page 275 where it's talking about time around the Earth, fact number one, it says the Earth takes 24 hours to complete a full revolution of 360 degrees. A circle is 360 degrees around, and that's why we have 24 hours in a day, because that completes the full rotation, and the sun will be back to its starting point. And another 24 hours, it'll be back to that starting point again. Notice in bold print, it says in 4 minutes, it rotates 100 degrees. What am I saying? 1 degree. There we go. So in 4 minutes, it rotates 1 degree. So you can figure out how much it takes to rotate certain degrees because you can multiply by 4. Each degree takes 4 minutes. So just jumping down to class practice, section 1, it says find the time required for the Earth to rotate these degrees in longitude. Okay, so A, 2 degrees. Well, if 1 degree is 4 minutes, 1 degree is 4 minutes, then 2 degrees would have to be 8 minutes. That's all you're putting as the answer. They just want to know how long does it take to rotate that far. All right, so B, 10 degrees, it would take 40 minutes. Go ahead and finish C through G, and then we'll go back up to the top section with the facts in a few minutes. All right, so hopefully you finished. Let's go over the answers. For C, 96 minutes, which can simplify to an hour and 36 minutes. So basically about an hour and a half to rotate the Earth 24 degrees. D, 20 minutes. E, 152 minutes, which is the same as 2 hours and 32 minutes. F, 400 minutes, or 6 hours and 40 minutes, if you simplified it to that. And then G, 68 minutes, which is an hour and 8 minutes. All right, so those should be your answers for the time frame when you're talking about the Earth's rotation, how long it takes to rotate that many degrees. All right, back up to the facts section. Number 2. Imaginary lines that run from the north to the south poles are called meridians of longitude. And we've already learned that in history. Okay, we've learned about latitude and longitude, and you can see, I know this is a very pale globe, but you can see the lines of longitude, okay, running long ways from North Pole to South Pole on the globe. All right, notice 0 degrees longitude passes through Greenwich, England. So I'm going to find England here, and I'm going to actually have to tilt the globe for you. So here's England. If you notice on my globe, it does label it finally down here, prime meridian. All right, that's the 0 degree longitude. And if you follow that up through here, where it passes through England, it passes through one specific town, Greenwich. It looks like Greenwich, but it's pronounced Greenwich because they're British, so why not? So if you notice, this line's called the prime meridian. It's the 0 degrees longitude. Greenwich, England is what it passes through. It's called the prime meridian. When Greenwich is exactly in line with the sun's rays, the time there is noon. Okay? Same with any place. When you are directly under the sun's rays, is when it's noon. Traditionally, it says noon is written as 12 m, but of course, we're used to writing it 12 p.m. Perfectly fine, same thing. All right, it's called Greenwich Mean Time. When we're going by the time there, when the sun's directly above Greenwich, that is noon in that time zone on that prime meridian. It's called Greenwich Mean Time. It was the basis for time around the world before 1970. GMT, Greenwich Mean Time, is based on the rotation of the Earth, but it can vary slightly because of the Earth's wobble. All right, it's not stuck on a stick, right? This illustrates the Earth's axis, but there are some slight tilting things that happen due to different effects, forces, and things like that. So what we use is coordinated universal time, and that's based upon the atomic clock, and that's what we use for our standard now. That's why your phones and your computers and things automatically update. They'll even change when it's daylight savings time, and it's why everything can be set at the same thing, because it's based on the atomic clock. So the UTC, this coordinated universal time, loses no more than 0.000001 second in a year. So it's extremely accurate. All right, number 3, until the age of modern travel, communities regulated their own time. Okay. However, in 1884, an international conference established 24 time zones. So throughout the globe, because it takes 24 hours for the globe to make a full rotation, they divided the entire planet up into 24 time zones. Okay, 12 are east of the prime meridian. Where's our prime meridian? I lost it now. Here we go. So 12 are east, okay, and then 12 are west of the prime meridian. So you've got half of them in one side and half on the other side, and then they meet at the international date line. Let's see if it's marked on here. International date line. There we go. All right, directly across from it. This print is very tiny. There we go. We've got the international date line. So the prime meridian is not like the equator, where the equator goes all the way around. The prime meridian does not go up one side and down the other. The prime meridian is the dividing line, okay? And you go east or west, and it meets at the international date line, just opposite of it. All right, the IDL, international date line, is opposite the prime meridian. And if you notice in the red part on your book, it's got it in a red marking, and it's like a little bit zigzagged. It's not straight like the prime meridian. It's not a full line of longitude. It goes around some land territories and islands and things like that, so that countries can be included in the same types of time zones mostly. So number 4, time zones, including the prime meridian and the international date line, differ from meridians of longitude in that they're not straight lines. Okay, so time zones don't always work in straight lines, as I'll show you when we get to the US time zones in a second. Okay, time zones are made to work within boundaries of states or countries as much as is reasonable. All right, so that's why you'll notice the red line for your international date line on your globe in your book is jagged. Like I said, they're trying to make it effective for countries, or in our case states, when they're dividing the time zones. All right, so number 5, it says that the time zones for the United States are Eastern, Central, Mountain, Pacific, Alaska, and Hawaii Aleutian. Okay, so your book doesn't provide that, but you might have seen something like this before, and we hear it oftentimes on TV programming announce, 3 p.m. Central Time or 2 p.m. Eastern. Okay, it just depends on what time zone you're in, what show it might be on. So we've got Eastern, which is our time zone. Okay, Central, and notice they're not straight lines. They try to include states as much as possible. Then we've got Mountain, then we've got Pacific. The next one over would be Alaska, which is way up here, and then still over further, even though they put it way down here, is like a little bubble in the map, is the Hawaii Aleutian time. Okay, so these are the time zones. It's not straight lines, but you'll notice, okay, specific states fall within those. All right, in each time zone, fact 6, the clocks are 1 hour earlier than a clock immediately to the east. So it's kind of going backwards. Whatever it is in Eastern time, it'd be an hour backwards from Central. Mountain would be an hour backwards from Central, and then Pacific would be an hour backward from Mountain. Alaska would be an hour backward from Pacific, and then Hawaii Aleutian would be an hour backward from here. And then if you kept going, it would go all the way around the globe for the different time zones. So if it was 9 a.m. here, it would be 8 a.m. here, 7 a.m. here, 6 a.m. here, 5 a.m. here, and 4 a.m. here. Okay, so each time zone, the further west you go, is going to be back an hour. Why? Because it hasn't gotten to that point of the sun yet as far as the rays touching those areas the same way it would here. So it can't be 9 o'clock in all places. All right. Number 7, a traveler going east across the date line actually has to set his calendar or his clock back a day. So if you pass the date line in the direction going east, you're actually back in the previous day. So it's weird how it does influence time, especially travelers. Okay. The westbound traveler, when you cross the international date line going the other direction, you jump forward a day. So it's possible to lose a day or gain a day back again with so many hours when you're crossing that international date line. Number 8, from the second Sunday in March to the first Sunday in November, many regions, we do, use what's called daylight savings time. It means the clocks are completely sent ahead 1 hour in standard time for that zone. And then, for example, spring ahead in the spring, fall back in the fall. So it's just to keep more daylight hours. And then by the time daylight saving time ends, we move it back and everything's back in coordination. But not every country does that. And there's even talk about certain states not wanting to follow it, which would throw time travel, not time travel, but time and travel across the U.S. into weird situations. All right, so for number 2, you're asked to complete the chart of the U.S. time zones. If you want to take a picture of this with your phone, that might be helpful to you so that you have a screenshot of what we're talking about and what the time zones are. But really, filling in the chart should be a breeze, right? Notice A is done for us. If it's 3 a.m. in Hawaii Aleutian, we go further west to Alaska, it's 4 a.m. Further west Pacific, 5 a.m. to Mountain, 6 a.m. to Central, 7 a.m. and then to Eastern, 8 a.m. We're not worried about other countries. We're just looking at U.S. time zone. I want you to fill in B, C, and D on your own. That should be easy. I do want to do E with you because we have to pay attention. Sometimes it's not all AM straight across or all PM straight across. Looking, for example, at E. E for number 5, number 2. Wow, where am I getting 5 from? They give us 12:48 p.m. Mountain Time. Okay, we know as we go east, we're advancing. So this should be 1:48 p.m. And it is important with time that we always put the AM or PM, and proper grammar, we do capitalize both the A and the P, even though it's pretty common for people to use lowercase. All right, and then this, of course, would be 2:48 p.m. Okay. Now let's start going backwards. We have 11:48, but why would you not put p.m.? We need to be careful that we're not just paying attention to the hours, we're paying attention to the time. 12:48 p.m. is just afternoon. This is still in the morning. 11:48, it hasn't gotten to noon yet. So these times are now going to be AM. So 12:48 p.m. here in Mountain Time is going to be 11:48 a.m. still in the Pacific Time. And then, of course, Alaska, it would be 10:48 a.m., 9:48 a.m. Oh, I forgot this one's a really long hyphenated one. It's not 2 separate ones. So it's still easy. It's just you paying attention to, wait, this is noon, afternoon, which 12 o'clock would be noon. This would be before noon, so it's still AM. So I wanted you to watch out for that one. Otherwise, the rest of the chart should be easy to fill in. Section 3, solving story problems. Again, using what we've learned about the time zones and the prime meridian. Number 4, you're changing from standard time to daylight savings time. Now remember, daylight savings time, you're setting it an hour ahead, okay? So that it's brighter earlier. It's giving us more daylight hours, all right? Number 5, converting to the whole degree. It's just a review of temperature. Number 6, solving equations and proportions. Number 7, just a mix of things, finding the answers. So work carefully. Watch your decimal point in problem G. Watch your order of operations in problem A. This is section 7. Please make sure that you're doing both the numerator and the denominator squared for problem B. Everything else is just some basic review skills, and we've been over them enough. I'm confident that you guys have those. So that's it. You're just going to finish this worksheet today, and I will see you next time. Hopefully you took a picture of this. Here's one more time. Okay. That might help you, and then you can have it for notes when we do time frames in the future, because it's going to pop up on a lot of our math worksheets moving forward. So that's it. Finish lesson 153, all problems, and I'll talk to you later. Bye.